Hello everyone, welcome back. In this lesson, we will continue learning about the operations of interacting with FMZ and Ethereum. In the Ethereum blockchain, each block and transaction contains rich metadata information. This information includes block hash, transaction hash, timestamp, difficulty value, sender address, receiver address, and transaction amount, etc. If you want to query this metadata information, you can call Ethereum RPC methods. Obtaining the metadata information of blocks and transactions allows us to understand the operational status of the blockchain network, the execution of transactions, and economic activities. This is important for Ethereum development, operation, and regulation. Therefore, it is necessary to call Ethereum RPC methods to obtain metadata information. Now let's look at the first example, function ethchainid. ethchainid and netversion ID has similar purposes, so we will test them together. Both functions return the ID of the blockchain that the RPC node is connected to, but the difference is that netversion returns the ID in dimensional format, while ethchainid returns the ID in hexadecimal format. First, let's take a look at the network names corresponding to the chain ID as follows. We can see that the Ethereum mainnet corresponds to chain ID is 1, and the Goerli testnet that we are testing corresponds to chain ID 5. So when configuring the Goerli testnet in the wallet, we need to fill in chain ID 5. We tested with configured Ethernet testnet Goerli node. It uses exchange.io function to call the API interface of the Ethereum network, retrieves net version and chain ID, and uses log to print them to the console. It is important to note that chain ID returns a hexadecimal value, so parseInt is used for conversion. We click on Execute. Wait for a moment, and we can see that the return results of both functions are 5 here. Now let's look at the second example, ETH gas price. By calling the ETH gas price method, we can query the current gas price on the chain. Gas price is an important parameter in the Ethereum network as it determines the unit price of gas consumed in a transaction. In Ethereum, each operation requires a certain amount of gas, and the amount of gas consumed in a transaction depends on the number and complexity of operations included in the transaction. Therefore, gas price can be understood as the unit price of ether required to pay for each gas. When executing transactions or contracts, it is important to set an appropriate gas price to ensure that the transaction is quickly confirmed and executed by the network. If the gas price is set too low, it may result in a long waiting time for confirmation or transaction failure. On the other hand, If the gas price is set too high, it will waste a significant amount of ether. Therefore, setting an appropriate gas price is crucial and should be adjusted based on the actual circumstances. By calling ETH gas price, you can obtain the current gas price information of the network to set an appropriate gas price. The ETH gas price function returns a result in hexadecimal format. Here we can write a function called toAmount to convert the hexadecimal string into a readable numeric value. Here we click on Execute. Here we can see the return result signifies that the gas price for this transaction is 1177299904, with the smallest unit of ether, which means that 1177299904 weight of ether is required to pay for each unit of gas. The ETH block number function is used to carry the blockhead. The blockhead is an integer value that represents the position of the current block. In the entire blockchain, each block has a unique blockhead that is one more than the blockhead of the previous block. As new blocks are added to the blockchain, the blockhead keeps increasing. Therefore, by querying the blockhead, we can determine the position of a block and how many blocks have been added to the blockchain before it. So let's take a look at the code. Again, we use toAmount to convert the value returned by block number to a numeric form. First, we query the latest blockchain head at Goerli etherscan.io. We refresh it, and we can see 9559208. Then we return to use ETH block number. To query the latest blockchain head, we click Execute. And we can see it has been updated to 9559209. It proved that the two return results are consistent here. Let's move on to next function, ETH getblockbynumber. The function allows developers to specify the block number to get the block information on the Ethernet blockchain, which provides the ability to query the data on the blockchain. To help developers browse the blockchain and transaction validation, and then the development and monitoring of the blockchain. Let's take a look at the code. We use ETH block number to get the current latest block number. Then we fill in the block number into the second function, ETH getBlockByNumber, to retrieve detailed information about that block and print them to console. Since the content output by log is too long and automatically tourniqueted, we use a for loop here to iterate through the returned block information fields and print them one by one. We click Execute. Wait for a moment. And here, the following are the metadata information of the block. These metadata information are important attributes about each block on Ethereum blockchain. The difficulty value, gas limit, and gas usage are indicators of network performance and efficiency. The block hash and parent block hash ensure the security and stability of the entire blockchain. The miner's address, nonce value, and the mixed hash value are related to the consensus algorithm. The transaction list and the transaction root hash reflect the actual transaction details within each block. This metadata information can be used for various types of blockchain analysis and provide necessary input data for developers to build smart contracts. RPC methods are state writing operations. Calling Ethereum RPC methods for state writing refers to the operation of writing state data to Ethereum blockchain using RPC methods. This includes creating new transactions, deploying smart contracts, and modifying the state stored by smart contracts. These state update operations can be called through the RPC interface to achieve the purpose of recording state data on the blockchain. We will provide a detailed introduction to these functions in the section on creating smart contracts using FMZ. Our course only mentioned a few illustrative RPC methods. If you want to delve deeper into Ethereum's RPC interface, you can refer to the documentation provided at this website. Here you can view details, the methods, and parameters supported by Ethereum API Gateway. Please remember to always prioritize your security and privacy when interacting with the blockchain. So that's all for today's lesson. See you in the next lesson.